Solving systems with matrices. By now you are probably thoroughly annoyed with having to do these kinds of systems, three variable systems, by hand. So, good news is there is another way. It's a lot easier, a lot quicker. But now that you understand the process of solving three variable systems by hand, we can go into other ways of doing it. So let's take a look at a smaller system first, and just the idea of matrices. So let's look at this matrix multiplication. Not being very imaginative with my entries at the moment, but that's okay. So remember when we're doing matrix multiplication that we get something like this. We go across this row and down this row, so it's 1 times 5 plus 2 times 6. And then this row with this column, so 3 times 5 plus 4 times 6. And if you look at our matrix product, you'll notice that these are the same number. These are the same number. We've seen stuff like that before in systems. So if we look back up at the system that I gave you at the beginning, oh look, these are all the same, these are the same, these are the same, except for instead of being 5 and 6, it's x, y, and z. So I can take a system and set it up into a matrix multiplication problem, just kind of going backwards. So looking again at that first system, we can take it and set it up into a matrix equation, and it would look like this. 3, negative 1, 2, 1, 4, negative 5, 2, 2, 3. So where did all those numbers come from? All of those numbers came from my coefficients on the left-hand side of the equal sign. So there's kind of this little separation here. Okay. The left-hand side, all the coefficients give me this first matrix. And it's getting multiplied by, well, what do all of these have in common? They all have x in common. So x goes here. What did these all have in common? Y. So y goes here. And the third row, or third column, all have z in common. So when I go through and actually multiply this, 3 times x, negative 1 times y, 2 times z. And that's what that first equation is. Same thing with the second row. X plus 4y minus 5z. 2x plus 2y plus 3z. Okay, so what does this equal? Because this isn't an equation yet, this is just a matrix multiplication, but we need an equation. Well, I know that all of this has to equal 3x minus y plus 2z has to equal 7. So the other side of my matrix equation is the actual solutions. So that's where I put the 7, the negative 6, and the 15. And these have little names. This first matrix, oddly enough, is called the coefficient matrix. Because it has the coefficients of the system. What do you think the second one's called? What does it actually contain? It contains the variables, so this is our variable matrix. And then this one has all of the numbers without the variables. Remember, that's called a constant. So this is our constant matrix. Or you might see it referred to as a solution matrix. So there's our constant matrix. Okay, so again, if we multiply these two, we get exactly this right here. It's just another way of organizing the equation so that we can work with it a little bit differently. So then the question is, how do we actually solve this? We'll go ahead and get rid of our system here. We don't need that anymore. Well, we can't divide by matrices. We need to get this matrix all by itself, but we can't divide by this one. So what's the same as dividing? Let's look at some basic math before we go into that. So if I just have the very, very simple equation of 5x equals 10, and I were asking you to solve for this, what would you do? You divide both sides by 5. So divide by 5, I would get x equals 2. Well, what's the same as dividing by 5? Multiplying by its reciprocal, or its inverse, multiplicative inverse. So this is the same thing as saying, okay, I'm going to take this and I'm going to multiply both sides by 1/5. So 1/5 times that times 1/5. So then 1/5 times 5 is going to leave me with x. 10 times 1/5 is going to leave me with 2. Same thing, just different operations. So with matrices, we can multiply by the inverse. We already know how to find the inverse, so now we just have to multiply by the inverse. So let's look at our general matrix equation for solving systems. And slide that underneath. So the general equation is AX equals B. X is your variable matrix, this is your coefficient matrix and your constant matrix. And when we multiply by its inverse, we want the inverse of A, because that's going to get rid of it. So we have two options here. Is it x equals B times the inverse of A? Or is it x equals the inverse of A times B? Does it matter? Yes, it matters. Remember that matrix multiplication order does matter. So how do we check if a matrix product is defined? Because here I'm saying B times the inverse of A. This says inverse of A times B. How do you check and see if those are defined? Remember, we have to look at the dimensions. So if I look at the dimensions of B, which is this one here, dimensions of B are 3 by 1. Dimensions of A, inverse, are 3 by 3. Remember, you can only find the inverse of a square matrix, so it's going to be the same. Is this product defined? Well, let's look here. Those are not the same. So this is not defined. So it's got to be this one, right? So let's take a look at this one. This is 3 by 3. And then this is 3 by 1. These are the same number. So yes, it's this one. Not that one. Inverse always goes before B. If you try and put it the other way in your calculator, it'll give you an error and get upset at you, and you'll be like, why won't this give me the answer? That's why. Has to be in the right order. Okay? So, generally speaking, x equals A inverse B is how you solve a matrix equation so that you can actually solve the system. And then you can put that in on your calculator and figure out what your solution is, and it'll take you a lot less time. And since you're masters at finding the solution by hand, you already know all the math behind it, so it's okay for you to use other options when you have different goals and different, yeah, there's another word for goals I was going to use. Anyways, now you don't have to solve them all by hand. Yay!